Hello, have you ever observed kids when they're learning something new? It's an extraordinary process that makes us rethink our approach to learning anything efficiently. Children are inquisitive by nature and are not afraid to fail because they love to experiment and learn. One of the strategies they use is called computational thinking. We are Pi Academy. Our mission is to empower students to succeed in the digital age. At Pi Academy, computational thinking involves 6 phases: problem definition, deconstruction, pattern recognition, abstraction, algorithmic design, and feedback loops. Let's see them in further detail. Problem definition is the process of asking the right questions to get clarity on the challenge at hand. Students learn to use inquiry to explore further details about the problem and record them. Facing large and complex problems can often be daunting. Deconstruction is the process of reducing a large problem into smaller problems, which are easier to analyze and solve. With a deconstructed problem, it is easier to recognize patterns and use similarities or differences to get closer to the solution. Abstraction involves filtering out the unimportant details, thus focusing only on the relevant information to solve the problem. The algorithmic design phase involves determining the steps and organizing them as a series of instructions to solve the problem or completing a task successfully. With the information and knowledge available, students take an experimental approach of forming hypotheses and testing the steps to solve the problem and improve the solution. Let's look at an example, starting with a challenge. How do you calculate the sum of numbers 1 to 4? Many would do 1 plus 2 plus 3 plus 4, which makes 10. Good, so how would you calculate the sum of numbers 1 to 10? Many would do 1 plus 2 plus 3 until 10. Some would already know the sum of numbers from 1 to 4, which is 10, hence 10 plus 5 plus 6 up until 10, which is 55. Now let's look at a more complex problem. How do you calculate the sum of numbers 1 to 100? Adding each number is extremely inefficient. We need a technique, so let's first deconstruct it. 1 plus 2 plus 3 until 98 plus 99 plus 100. When we add the first and last numbers in every step, we get 101. How many such pairs are there in 1 to 100? 50? Yes. So we calculate 50 times 101, which is 5050. How did we get there? It is 1 plus 100 times 100 divided by 2, the pairs. As a process, we get the maximum number. Calculate 1 plus max times max over 2 and show the calculated value. As an extension, how would you test with 500, 1000 or more? How would you extend to odd numbers? Let's label these phases, starting with problem definition, deconstruction, pattern recognition, abstraction, algorithmic design, and feedback loops. All these phases together enable computational thinking. With a group of extremely passionate and skilled educators and a strong curriculum, we aim to empower students to drive their own learning paths and solve bigger problems to make this world a better place. The Future of Jobs Report 2020 from the World Economic Forum suggests that 84% of employers are set to rapidly digitize working processes. Analytical thinking, active learning, complex problem solving, critical thinking, creativity, leadership, and technology use feature in the top 10 skills of 2025. If you wish to give your child the most precious skills of the 21st century, reach us at info@piacademy.com.au or visit our website www.piacademy.com.au for a no-obligation, free trial class. All the best. Thank you.